Thank you so much for being here. I know we're right after lunch, but hopefully this topic will be exciting enough that it'll supersede any post-lunch effects. So thank you, Joanna, for the introduction. I'm a physician. I'm an internal medicine hospitalist. I practice in the hospital. I'm the medical informatics director for digital health for the health system, which means that I work with our team to design, build care models enabled by digital technologies, but also technologies like AI that we then implement for our patients here at Stanford. And I also direct this lab called the Stanford Emerging Applications Lab that builds and tests some of these emerging applications. This is a really exciting topic for me for many reasons. I've done a little work with AI, but mostly just I'm thinking about this from the perspective of just a human being, in the world, a user potentially. I have a ChatGPT account like the other 100, 200 million people in the world. As a physician, as an educator, so I was actually rounding in the hospital last week, and I'm on the teaching service, so I have my residents and my medical students. And I remember walking into the team room, and the medical student was there, and clearly she had ChatGPT open right in the browser, and I walked in and she immediately minimized it. And I actually wanted to tell her, no, just leave it up, right? In fact, I will tell my residents in the beginning of the week, you guys have a ChatGPT account? Open it up. Now, you cannot use protected health information in ChatGPT. Hopefully everyone knows that. So you cannot use it for actual clinical care. But there are so many aspects of clinical care that's not necessarily diagnosis, not necessarily anything that requires PHI, but involves a lot of text synthesis, insight, right? Stuff that large language models clearly have shown to do well. Even something like, hey, I just had a conversation with a patient that was really confusing to me, and I want to be able to reframe it in a way that's more palatable to his or her situation. Give me some talking points. It works pretty well. So here's just an example of something that is already being used in healthcare that doesn't require any PHI, and it's not anything about diagnosis. What that, I think, is showing is just how ubiquitous AI is now in the world that is very different from even a year ago. When it's Stanford, we've talked about AI in healthcare for quite a while, and for a while it's been somewhat of a niche topic. Of course, more people here are interested than others, but it's one of those things that it existed in a bubble. Now it's everywhere, and that's, I think, what we'll actually be speaking to a bit during this panel. Not only is all of this very transformative because there's machine learning advances in the ability in what these models can do, and there's I think some of our panelists will speak to what's special about generative models and why there's so much excitement there. But also, and I think David will speak to this, there's just like this almost like infiltration, and that's kind of a negative word, but either way, like this integration of AI now into your daily life to the point where my parents are talking about AI, and they're not AI or technology people. So what impact will that have in the real world? How do we think about this? We have the privilege of talking about this somewhat early, and I think we all probably have a sense that we kind of don't really know what we're talking about in some ways. We're at the very, very nascent stages of AI in the same way that the early days of the internet, people were super excited about sending a message or sending an email. They probably never imagined how the world was going to change, what new business models, what new care models for healthcare will be enabled. I think of the same thing with AI. We're really just thinking about the building blocks right now, and the degree of complexity has now increased exponentially because of the way these models work, the fact that they're outputting not just a number or a classification, but it's outputting language and images in a way that is much more complex and rich in information. But also the number of people now who are engaged in the conversation, that also exponentially increases the complexity. So how do we think about that? So with that, I'll introduce our first panelist. And what we'll do is we'll have each panelist give a 10 to 15-minute talk. We'll save questions for the end, and at the end we'll kind of bring everyone back up. I'll ask a couple of questions first, and we'll open it up to the audience. Thank you. I'll start with Jason Fries. So Jason is a computer scientist at Stanford in the Stanford Center for Biomedical Informatics Research, and his work is really focused on enabling domain experts to rapidly build and modify machine learning models in medicine. Does a lot of work with large-scale expert-labeled training data, a lot of work with weakly supervised machine learning, and I'm sure he'll say a ton more about the work that he's doing. So, Jason, welcome.
Wonderful. Thanks, Ron, for the introduction. So yeah, I'm Jason Fries. I work largely in the Center for Biomedical Informatics with Nigam Shah, presented this morning. And today we're going to talk about our work on generative AI for electronic health records. And so, as Ron sort of suggested, we've had this amazing moment where suddenly generative AI becomes the mainstream. You're in a universe now where a niche academic topic is something you'll overhear on the train, or like recently being made fun of by people in coffee shops. Like it's transcended into a thing that your average person now knows about. And with all the excitement comes sort of the skepticism and concerns about their ability to hallucinate, make up information, and sort of potentially even deceive users in some way that's very compelling because it uses natural language. So everyone's fixated on sort of ChatGPT and the OpenAI large language modeling space. But these are sort of, there's a general, larger class of models that are called foundation models. That's a term that's coined on this campus by Percy Liang and several other researchers. And it really captures this idea that we've started to transition to how AI models are sort of built, conceived, and deployed. And we have a universe now where we can take millions and millions of data points, or billions and trillions in the case of OpenAI, and train a very powerful model that serves as a foundation for building other models. And unlike sort of classic machine learning, where you take a single task and sort of train your model with whatever data you're able to get your hands on, you now have this very flexible, generalized artifact that can be adapted to many tasks with a lot of desirable properties. And this runs across multiple modalities. We focus on language a lot, but from imaging and language, imaging and audio to other kinds of domains, we really see a shift to this sort of new paradigm of conceiving AI. All sitting on top of this is now the ability for humans to interact with these artifacts using natural language, which creates a very powerful and opens up a lot of opportunities and challenges for how we conceive of ML and AI operating in society. And so, we conceive of these things as massive sort of like things built by the big tech players. But in the open source community, we see this huge trend, particularly this year, of just rapidly replicating in an open fashion the big innovations coming out of OpenAI or other big tech companies. And there was a leaked Google memo a few weeks back just talking about how these tech companies don't have a moat. Like they don't have anything special. These artifacts are becoming commoditized and accessible to everybody. And we had a moment where some really great work here at Stanford called Alpaca about sort of distilling information found in GPT models and doing it on the real cheap for something like replicating a model for $600. And it suggested a sort of really promising way to sort of get a free model of amazing abilities. But we've seen sort of very recently some kind of skepticism of that perception. And what brings us back is to sort of the same place, that we have to do the heavy lifting and hard work of building. If we truly believe in this foundation model mentality, we need to do the heavy lifting and hard work of building a base model that we can rely on and trust, and it doesn't come easy. So we have a lot of thought leadership on this idea of medical foundation models. We have a number of blogs through the HAI through that website, particularly on how AI foundation models can be used in AI, and then particularly how shaky and sort of suspect a lot of the ways we evaluate these models are. And we kind of proposed, not an exhaustive, but a simple list of dimensions and axes by which we need to start thinking about better ways to measure foundation models. These are things like classically we focus on accuracy, but increasingly it's stuff like less labeled data, making it simplified deployment in the hospital. We heard a lot of great stuff on that this morning. Multimodality, and particularly the ability to interact with humans is paramount to understand, measure, and make better for the people that actually have to use these tools. And so there are kind of two big worldviews of medical foundation models. There is the big language model paradigm, which is inputs are documents and outputs are text. This is the kind of ChatGPT view of the world that's got everyone so excited. But there's also another paradigm that we in our lab have a lot of experience working with, and this is what we call foundation models for electronic health records. And that's where, instead of viewing documents, you move to entire timelines of structured medical data. So basically this is, can we take the entire patient history and learn a representation of it using a machine learning model that can be then used for downstream machine learning tools. And in this, the input is this whole notion of patient history, whatever that may include, and then an emphasis on using that embedding or feature that comes out of that model. And so the key insight on sort of, how we can do such a thing with structured data is that we just view an electronic health record as a sort of weird language. Natural language, of course, has order and structure based on syntax and other, semantics. For an EMR or EHR language, we're just concerned about the order in which these artifacts or these medical codes we've defined occur over time. And it turns out there's also structure and meaningful signal in the way that those are ordered. And using the same technology to train a language model is naturally can naturally be applied to these structured language models. And so the big picture idea that we've worked on in our lab, particularly our PhD student Ethan Steinberg, is let's train a machine learning model over everyone in Stanford medicine and use that to build our foundation model that we then can train at a massive scale and then adapt to the many, many other little use cases or large use cases that may occur in the hospital while having the huge advantages brought by foundation models around better performance, more robustness, faster to train and modify. And so this sort of hypothesis is that there's some shared information or structure between every human who goes to Stanford. So we have a lot of work under these themes. Our first work was this paper called Climber, which was to take this language model idea and train on everybody. And what we found is that we got up to a 19% increase in overall AURC performance. Don't glom too much on metrics. I think metrics are complicated. This is just a loose indicator of utility. And if you were to take that model and evaluate how well it performs against sort of state of the art, it decays 43% less performance over time versus sort of a standard approach. And it appears to be more robust when you take that model and transfer it across subgroups. So it has all these really attractive properties. We have a follow-up paper that Ethan has been working on where we move from classification models to time-to-event models, where we're less concerned about, sort of a rough notion of if something will happen, but predicting actually when it will happen for prognosis and other sort of clinical decision-making. In this approach, we find that it's not only 8 times faster to train than current state-of-the-art, but you need 95% less training data. So you dramatically improve your ability to use a few examples to train a powerful model. The story isn't only models, pre-trained models, though that's a huge thing in this foundation model era, but it's also shared data sets that we can evaluate performance on. And that is a particular area in health AI that has been challenging for various reasons, and where I feel like AIMI has done a really amazing job of sort of leading and making sure diverse types of data can be made available. So in conjunction with AIMI, we're working to release 2 data sets. One is called Earshot, which is a fully de-identified 7,000 sets of patients, full longitudinal EHR data, and a standardized benchmark for measuring that sort of few shot or how many examples you actually need to train something. And we're in the process of releasing or getting set up to release a data set of 20,000 patients, including CT scans, longitudinal EHR, and radiology notes, and diagnosis and prognosis labels for standardized benchmarking. And so we hope this really contributes to this scarcity of data where machine learning folks really want to help and build new methods, but they're really only using mimic. And we don't have this good notion of transfer learning and all these other exciting properties of medical foundation models that we want to test. And so I just want to sort of wrap up with this sort of idea of these two worlds of evaluation. On the left, we have natural language. This is stuff like, I need to pull certain information out of a medical record. This is commonly called information extraction. You might want to be interested in some fact or some critical bit of information. A lot of problems fall under that bucket. You may now, in this new era, be interested in assistive writing, where you may want to write drafts of notes or messages to patients, or rephrase a note so that it's, if you don't have time to write a really nice letter, maybe you want GPT to make it a little nicer when you send it. So all these types of helping tools for drafting language. And then, of course, just more complicated question answering and information synthesis. On the other side, you have these more like academic kind of currently things, like I'm interested in risk stratifying patients, or I'm interested in time to event models, or phenotyping individuals so that I could build a clinical trial recruitment or do my study. And those tend to not be sort of, they tend not to be formulated as language tasks, but more like classic EHR research tasks. And if you were to look at these from the perspective of like reproducibility and open models, the left side has a lot of open models and the right side has virtually nothing. So you can't replicate any of sort of the advantages that we have found in training these models, which is a huge reason why we're pushing to release a lot of these as part of our papers so that other institutions can evaluate our performance. And so there's no holistic view and we really need to do a better job. And then just finally, work that we're spinning up now, like why do we divide codes and text? Why do we view these as artificially separated things? Can't we combine them? So we are working on training a large language model that focuses on capturing all of patient history and combines codes and language so that you can interact both naturally, do sort of writing tasks, but also do all these sort of risk stratification and more complicated sort of reasoning tasks. With that, I just want to say that I really liked the talk this morning that really said that we need to move to a universe where we look at how AI enhances our ability, not replaces our ability. And really, the key to any adoption here is building new evaluation tasks where humans are firmly in the loop, and we look at how their ability to use AI tools effectively actually materially improves people's and patients' lives. So with that, thank you.
Thank you so much, Jason. Next, I'd like to introduce Katie Link. Katie is a machine learning engineer at Hugging Face, where she leads healthcare and biomedical applications of AI. And before Hugging Face, she co-led the creation of the largest open data set of longitudinal brain MRIs. And this is at NYU. So she's currently in New York. She is actually on leave as a medical student at Mount Sinai. And before medical school, she was an AI resident at Google X and a data scientist at the Allen Institute for Brain Science. Katie?
Thank you, Ron. So today I'll be talking about what many people have been talking about, the movement towards using generative AI in healthcare. And I do want to try to motivate us to think that maybe openness and open science principles are possibly one of the key components of this movement. So a bit about me. I'm a machine learning engineer at Hugging Face, as Ron mentioned. I lead healthcare applications of artificial intelligence, and I'm also a medical student between my second and third years at the Icahn School of Medicine at Mount Sinai. You may have heard about Hugging Face if you're an AI researcher or engineer. We are a collaborative open platform of machine learning models, data sets, and interactive demos. We also maintain a number of open source libraries, like our popular Transformers library. We also have an open source chat UI called Hugging Chat. And maybe you have deduced that our mission is to democratize good machine learning. And traditionally in machine learning research, open science has been part of the culture that has really driven a lot of the rapid transformation of artificial intelligence. Researchers commonly share code, model weights, demos, which really allows other researchers to build upon those results, reproduce them, and interrogate them. However, in medical AI, we've been a lot slower to have this open science culture really permeate. So, for example, 2% of radiology AI articles shared both code and experimental data. And as shown in this paper, we're really lagging behind a lot of the computer vision and natural language processing papers in using public data sets and sharing code. And there's many reasons why it's really hard to do this in medical AI, but I have a lot of empathy for this process. I was part of the team that created one of the largest data sets of brain scans. We're also working to open source our code through open source libraries like Manai. And really, as many people have mentioned prior, there's this chasm between implementing AI, developing it, doing research on it, and implementing it in the clinic. And a lot of experts think that one of the reasons that this we might be able to make progress on this is through changing our culture to be more open science friendly. And for the most part in medical AI, we've been really focused on discriminative algorithms. These are your classic image classification, object detection, segmentation algorithms in computer vision. These are also your classic prediction models. Traditionally, these were trained on large amounts of labeled data. Now we're seeing this movement, obviously, towards generative AI, where you can give, for example, a text prompt, and a text generation model will be able to complete that paragraph or longer story. And so there's some generative AI tasks that we've have come out in the last couple of months. For example, text-to-image models, where you can give it a text prompt, such as a small right-sided pleural effusion, and it will generate realistic-looking medical imaging, such as these synthetic chest X-rays. Question answering is also a very popular use case, for example, consumer medical questions. And a lot of the focus has been around these large language models, especially in the past few months. So just to give a kind of a quick overview of what this training recipe looks like currently. So you'll start with a base model that's usually billions of parameters randomly initialized. You'll feed it a lot of unstructured, unlabeled data. This can be text data, but it could also be things like proteins, amino acid sequences, or, as Jason mentioned, ICD-10 codes. And so maybe it's better to think about these more as large sequence models, but right now we'll just focus on text data. And so after training it in a self-supervised manner on all of this text data, you'll come up with this really powerful pre-trained model or foundation model that has gotten a really good representation of whatever sequence you're training it on. And then you can kind of go back to your classified or your classic supervised fine-tune methods, where you could, for example, train it on a number of medical licensing questions to have a really good USMLE model. You could also do PubMed QA, but there's a number of different tasks you can fine-tune your model on. You can also just generally train it on a large instruction tuning data set, for example. This is also pretty popular right now. The next step, which is still very new, is called reinforcement learning from human feedback. I won't go into too much detail on how this works, but just as a brief overview, first you'll train a reward model from human feedback, and then you'll fine-tune your original language model based on the reward model outputs. And so with these new large language models, we've seen a number of them being evaluated or used within the biomedical space. And there's been some kind of key components of how these have been trained within specific domains like biomedicine. You can first pre-train your model on biomedical text. You could train it on general text and then fine-tune it on biomedical text. Or you can take a generalist model, train it on a lot of instruction data sets during your fine-tuning mechanism, and then use RLHF to make it more chatty. So these have all been kind of evaluated within the medical space. There are a number of ways to then improve your model's usefulness outside of the training regimen. So for example, prompt engineering is a very popular method these days. Things like chain of thought reasoning, where you prompt the model to create kind of a sequence of thoughts. For example, like think step by step is one really popular prompt. Also to kind of critique its past outputs is another really popular method in prompt engineering these days. Retrieval methods are also very popular, especially in order to ground your model in factual information and update the information that it can pull from, as well as using tools such as APIs or even smaller specialized models as well. And so one really nice example of this currently being researched, this model uses a vector database to retrieve information. It also then uses a calculator to really factually answer some of these expert medical questions. And so with all of these generative AI models that have been really popular over the past few months, we've seen a number of possible use cases emerge, which might be, some people might consider to be the future of generative AI in medicine. However, I think that it's still really important for us to think back to some of the pitfalls that we encountered with discriminative AI models and see if they still apply to generative AI so that we can hopefully avoid them while moving forward. Some of these include the problem selection, making sure that we're identifying meaningful problems within clinical medicine to apply generative AI, really utilizing the power of these models. Increasing data set and model transparency. We still have a lot of questions on what a lot of these models are trained upon, and it seems we're moving towards a world where this information is becoming less and less transparent. Model generalization across different subgroups or different sites could still be a big issue, as well as degradation of the model's performance over time. Meaningful evaluation in the real world. This is obviously always a really big issue when we're thinking about deploying these models in medicine. We want to be able to know that they're safe and effective. And then, as many people have talked about, human-AI interaction is still going to be a very important thing for us to consider going forward. Things like automation bias, especially with some of the new pitfalls that that generative AI comes with, such as hallucinations. This is something we really need to be focusing on as well. There are also a number of new pitfalls that we're encountering while researching generative AI in healthcare. Some of these include that these models are very general purpose. They can be leveraged for a broad range of tasks. And this means that if we use a model that has, for example, biases in it, that those biases can be then applied to a number of tasks downstream. So we need to be mindful of how that negative impact might scale. Hallucinations or confabulations are still a big issue, where a model might sound very confident but output incorrect and factual information. Different types of adversarial attacks, such as prompt injection, are also becoming more and more useful, or we're seeing those more in social media, for example. Continuous model updates, where the model is being trained on human feedback and how that can change how we continuously do validation. These models can regenerate training data, which obviously has a lot of privacy implications. And the way that we share data through, inputting your prompts into different chat UIs. Obviously, we need to be mindful of what the consent process of that is like, what the security of that data is. And finally, human feedback and evaluation is a really important part of these models. So we need to be thinking about, where is that human feedback coming from? Is it coming from biased sources? Is it coming from certain demographic groups, et cetera? And so I believe there's a lot of benefits for openness, particularly in kind of addressing some of these pitfalls. One being the increased transparency that comes with open sourcing these models. For example, these are some of my colleagues on the ML Society and Ethics team at Hugging Face have created this nice interactive demo where you can look at different diffusion models and see what the average faces look like for different groups of people. So for example, they've inputted the compassionate doctor, and these are the different average faces that come from some of the different diffusion models that are currently out there. It's important for us to be able to reproduce different models and their evaluations. And finally, making these models more open increases accessibility, not just to other AI researchers or engineers, but also to other stakeholders within domains such as medicine, like clinicians and patients. And finally, there are also a lot of challenges, though, with openness. Patient privacy, as I mentioned, these models can regenerate patient data. If you open these models, they can be used for unintended uses, both malicious uses like spreading medical misinformation, or non-malicious uses like patient self-diagnosing. And they're also still very difficult to deploy, especially safely, where you have different moderation tools or other types of systems that are built upon these models to make them safer. These are very difficult to deploy for people who are just taking these models out of the box. And so luckily, we don't have to necessarily think about openness as binary, open versus closed. We can actually think about it as a gradient. And so one of my really fantastic colleagues, Irene Solomon, recently published this paper on the gradient of generative AI release. There's really a number of different options we can consider when we're thinking about releasing generative models. And so to kind of sum up here, I just wanted to kind of go over some best practices when you're thinking about maybe sharing some of these generative biomedical models and demos. One, to be formulating a release strategy based on some of that gradient that was previously described. This is especially important if you're using patient data to make sure that it's compatible with the data sharing policies of the patient data that you used your model. Obviously, to invite a multidisciplinary discourse among different stakeholders when you're thinking about releasing models and demos. Being mindful of your model's license. So you have a number of different license choices you can make when you share a model. I'd recommend considering some of the responsible AI licenses, also known as RAIL licenses. These are really great responsible AI licenses that have specific language for medical models as well. Creating informative and detailed model and data sets cards can really impact the model's transparency, as well as kind of define different use cases or unintended use cases. When you make your model card, consider including disaggregated evaluations of your model so that other users of your model know how it performs on different subgroups. When you create an accessible demo for your model, you really are able to access a broader range of audiences to interrogate or build upon your model, such as non-technical audiences. Being clear about medical claims is important for regulatory purposes, for example, and also any user agreements. You want to make sure that your users are consenting or having informed consent when they access your model. And finally, when you do release models, it's also important to release documented reproducible code so that others can more easily build upon your work. So thank you for your attention.
Thanks, Katie. And finally, I'd like to introduce Dr. David Magnus. David is the Thomas A. Raffin Professor of Medicine and Biomedical Ethics at Stanford, and he's also the director of the Stanford Center for Biomedical Ethics and an Associate Dean of Research and many other things. So I'll have David introduce the rest of his background. Thank you so much.
Thanks, Ron. Thanks very much for having me here. Two disclaimers to start with. First, this is going to be a little rough because this is sort of new content that I'm trying out. I'm kind of excited because I have kind of two main labs that I sort of run where we do research. One is around ethical issues in AI, and the other is a group that studies communication between patients and physicians. And we use tools from linguistic and linguistic anthropology and philosophy of language to do that. And they've been very separate, and it's kind of exciting for me that this is my first chance to publicly try and link these two very different things that I do and work on. So sorry, I apologize in advance for making you guys all guinea pigs. And I'm gonna really be focusing on the use of these generative models in general, but especially large language models, and the downstream use of them in clinical care, what it might mean as these are being implemented clinically. There's a whole other set of issues that arise in just the research to develop them that I'm not gonna be really focusing on as much. Okay, so first, just point out that the ethical issues that I and a whole bunch of other people have been writing about in AI apply to this particular the uses of large language models and AI in healthcare, right? So ways in which biased data leads to discriminatory outputs. Obviously, there's for some of these LLMs, there's much larger training data set. So some of the problems that arise in AI and healthcare that's arisen might be avoided by that. But at the same time, my understanding is, from what I've heard, the internet might be somewhat biased, and so it still can be a biased source, even though there's a lot of biased data is still biased. Also, there can be and one thing that's very interesting about this, and I appreciate the fact that we're starting to talk about prompt engineering, because it's fascinating to see how you get very different outputs depending on how the prompts are worded, and prompt engineering is really a new skill that we're going to need people to be able to do. But obviously, there's still bias in the data. I love this line that's been attributed variously to the Talmud and Anais Nin. We do not see things as they are, we see things as we are. And so ultimately, what we get out of these kinds of data is just a mirror on the biases and the things that we have in clinical care and in society that are then reflected in the data. So none of that's new in AI, and there's a lot of literature talking about it, and it's going to be true in this area too. Privacy issues, will more patient data be put into new LLMs that are more clinically specific for training purposes? You already heard an example. The answer to that is yes, and that creates all kinds of privacy issues that need to be worried about, security issues. Well, that's something that we've been dealing with, again, in AI for a while. You'll need consent. You've already heard discussion. Do we need to get consent from our patients before using their data in these kinds of research and clinical applications? That's going to be another set of challenges. But again, ones that we are used to dealing with when we think about AI and the uses of this data. And then finally, issues around accountability and liability. When you start using an AI in different roles in clinical care, is there a notion of, who, if something goes wrong, who's ultimately responsible for that? Is it the clinician who utilized it? Is it the people who designed the model that wound up having systematic problems that led to patient harm? And there's, again, a pretty, not huge literature, but Glenn Cohen and others have written about liability and accountability issues in the uses of AI. All of this stuff is, while going to be very present for the uses of LLMs. These are things that we've been writing about for the last 4 or 5 years and thinking about for a while, and there's some sense of sort of at least pointing the direction of what it would take to get from here to there and being able to deal with these things. So today I want to talk about the new issues. I mean, there's lots to be said about all those old issues, but I've published a bunch on that. Other people have too. I want to talk about new issues that are raised by the uses of these large language models in healthcare. First of all, is there a right to know you are talking to a bot? Is there a right to know that a bot was used in formulating a care plan? I'm going to talk about the problem of anthropomorphism of AI, which is a pet peeve of mine, and then I'll talk about consent and privacy of the data from users of LLMs. And I'm going to go through these in reverse order. So let me start with consent and privacy of users. So in addition to the worries about the data that's being used for the generation, ultimately, the companies that are building these large language models hope to make money out of them, which means they're hoping to supplant things like Google, which means it's not just that they're getting data from the internet, it means they're also going to have to get data from the users of all these things. So every time you go into ChatGPT and enter a query, there's going to be information about you and about the queries that you enter in, and presumably at some point they're going to have to figure out how to monetize that through advertising and other things as they learn about you from the different kinds of things that you enter in. So that's going to raise all kinds of interesting challenges, because sometimes, if you want to improve your grant submission, you want to work on this article you're writing, you want to figure out whether the data that you're thinking about publishing should be organized one way or another. Now you've entered it in. You've now given that data to a commercial third party, and so that could raise some interesting challenges. Will that wind up being accessible to others? Depends probably on the large language model and the company. Could this be commercialized in ways that people will find unacceptable? I mean, potentially, yes. People are a little bit freaked out when they find out what Google does with our information. On the other hand, we sort of adjusted to it, so it may be that we don't really care in the end whether or not learning from our prompts from ChatGPT bothers people any more than learning our search histories that Google does. Maybe it won't bother people anymore, but people should at least be aware that this is what's going on. worry that already was mentioned earlier, if healthcare data or images or anything that's protected health information wound up being entered into for research or clinical use purposes in a way that's not HIPAA compliant, I have a real worry about that, especially since a lot of these companies are really not set up to think about HIPAA and are not covered entities. And so I'm very worried about that. And in spite of the say that, of course, nobody would do that, I see a lot of non-compliance related to breaches of information. I am confident that protected health information has already been uploaded into ChatGPT by individuals, and I am confident that it will happen again in the future. And so that's just something that we really want to flag and make people aware of, to be very, very careful, especially as fine-tuning of the models happen explicitly for clinical purposes. I think that risk was going to go up. Okay, I want to talk about my pet peeve, which is anthropomorphism. Can't do an ethics talk without at least referencing a TV show called The Good Place, which I don't know if any of you have ever seen. But this is Janet. Janet is essentially a model. She's an artificial construct who helps people navigate around. And at one point in the plot, they need to delete her, and so they're going up to delete her. As she's leading them helpfully to the place to do that, because that's her job as an assistant to help people navigate. Here's the button you need to press to delete me. And then she warns them that, I remember, I have no feelings, I can't die, I'm just a construct. But we have a fail-safe mechanism, so I will, try and plead with you and stop you from doing it. And as they go to press the button, she says, please don't kill me, I don't want to die, and all those things, and they back off. At one point, she pulls up a picture of her 3 children and says, please don't deprive Skippy and Jimmy and Billy of their mother. And then they back off. She says, again, remember, I'm not alive. This is just an image taken off of the internet. It was from a Nickelodeon concert. So, right? So anyway, but the anthropomorphism that's built in is, I find, at best, a pet peeve, but I think at most, it's potentially worrisome. And it's one thing when it's just done by people in the public, but the worry in that article that was published in AJOB Neuroscience is that this kind of language doesn't just permeate the public, but researchers, programmers, and designers. And we've already heard everybody using it. I hate it every time I hear anybody talk about terms like hallucinations. ChatGPT does not hallucinate. Right? And what it does is it functions in the way it is designed to function. It is not a problem with a car that it cannot get you to Chicago in one day. You need an airplane to do that. It's designed to do certain things, and it does those things, and that is not a hallucination or anything else. It has to do with the way it's designed. Talking about understanding is at best wishful thinking, but it may also lead to problems, right? Because if you start to think about this in a certain kind of way as an agent and think about these problems in this way, you misunderstand the nature of what the thing is, and I worry that may lead us astray in what the real nature of the design problems are. It's not a glitch, it's a design feature. Now we have to think of it differently, and that's different than when you think of it as an agent. Anyway, so that worries about me. And we have to always remember that, like Janet, the behavior of ChatGPT and these LLMs is purely syntactic and not semantic. 2 days ago, I entered into ChatGPT, what is the name of the only grandson of Paul's grandfather? And the answer I got was, this is just an open source AI. I don't have enough information about who Paul is or any biographical information that will allow me to make this judgment, allow a judgment to be made about this, right? And so that's right. That it doesn't think of things in the same way. It's making a prediction based on a string and what the most probable next sentence is. It's important to think of it that way because what was mentioned earlier, the sort of certainty that comes out reflects this anthropomorphism, and it also is a function of a design feature. When you do Google searches, because of that probabilistic nature of the algorithms that are used, you get a whole range of answers. You don't get that with ChatGPT, which leads to thinking about it a certain way, but that's just a design decision was made. They could have had outputs that have probability is that this is what would be next, but there's a 98% chance that it would be this. 92% chance it would be this. They've chosen not to put the outputs that way, but it's easy to misread into it things that really shouldn't be. Okay, so now let's get to the even meatier issues. Do patients have a right to know an AI was used to formulate a care plan for them? And there's a split in the literature about how to think about that. Glenn Cohen has written a nice piece laying out some of this that will be coming out in the American Journal of Bioethics that I'm the editor-in-chief of. One way of thinking about it is that, look, generally, and he's thinking this from very much a legal perspective and what courts are likely to say about this issue, right? Patients generally are entitled to the information that a reasonable patient would want to know. And so if it's something that they would be entitled, a reasonable person would want to know, then that's something that they should know. And he made an analogy with if you, at the last minute, without the patient's knowledge, you substitute a different surgeon to come in and perform the procedure, in general, and there's been some court cases like this, reasonable patients might want to know who's operating on them, and therefore this is information that would have to be given to them. And so if an AI is used in their care plan, that would suggest that patients have a right to know that. The second approach is to point out that, well, we don't generally explain in detail all the factors that give rise to physician judgment about why they're doing things in their care plan, right? We don't go through, well, this person trained at Harvard. If they had trained at Stanford, they probably would have done things this way, but because they trained at Harvard, they like this approach. And also the drug detailer who came by their office, this drug company uses cheerleaders that are really cute, so they like them, whereas this company just buys lunch and this person's dieting a lot, and so that's why they like this drug better, right? We don't go into any of the various factors that govern why physicians formulate the care plans that they do, and that's generally seen as outside of the things that people can reasonably be asked to know about. And so to some extent, the answer to that question, should this be seen more like background, knowledge, they attended a conference, information that they've gotten, or is this more like substituting the surgeon judgment, changing who's the one who's really responsible for what's going on? Probably depends to some extent on how the AI is used and utilized. And so, anyway, so that's just there's a lot more work to be done for distinguishing these two and figuring out which examples belong in which bucket. Okay, now let's talk about conversational AI and some of its uses, because that's already here and going to be here more. I mean, right now we use AI in our text when you text people, and it sort of suggests things to say, right? This is probably the next word you want, and you can just do that. This is, more and more of this is, LLMs are like a version of that on steroids, right? And given that over COVID, the dramatic increase in the number of email exchanges between clinicians and patients has exploded, obviously real applications and use there. And then there's also conversational aspects of clinical care that are important, including therapy. So here's an article in my journal about the uses of conversational AI in psychotherapy, and whether or not there's a right to know that you're communicating with a bot. So there was a mental health app to try and help volunteers write messages more quickly, and basically using AI to really generate messages to help people with their, which was what this app was designed to do. However, once people knew that they were communicating with a bot, even if the messages were the same as what they would have gotten from a person, the efficacy of them dropped. So knowing who said it's not just about the message, and that's something I want to emphasize a lot. It's not just about the content of the message, it's the context, and that includes who people perceive it to be coming from. And so that seems to make it less effective. In that study that I just mentioned, the success of conversational therapy sometimes depends on recognizing that your interlocutor is a person and not a tool. So it may have use as a tool in the therapeutic realm, but it can't be a substitute, because that concept that you're talking to an actual moral agent, a human being, may be important for the therapeutic success, regardless of what winds up being said. And here's a really interesting report from outside of healthcare that builds on some of those things and amplifies them in ways that I found really interesting. They were looking in a couple of different contexts with fairly large studies of communication between people, some in more informal social occasions and some where people were working together to help formulate a policy. And it was one of those things where it was sort of an upgraded version of, give you suggested text to use in your communication tool. And then they studied the quality of the communication, as well as whether people thought that they were communicating, which queries did they think were AI generated and which weren't. And there were three findings from these studies. First, people were terrible at knowing when they were interacting with an AI-generated response or not, and in both directions. Some things that they thought were AI-generated weren't, and some things that they thought weren't AI-generated were. Second, if people believed a response was generated by AI, they responded negatively in multiple dimensions. So it had a negative effect on communication when people thought they were communicating with an AI. However, because of the first point that people were bad at making the predictions, the actual AI-mediated communications were better in multiple dimensions than when it was not used. So it has both better, but as long as people don't know about it, right? And yet lying is not a good solution and not one that's going to be very sustainable. So what I think this highlights is something that I think is important to think about, which is it's not just about syntax, and it's not just about semantics, the meaning of the words or the words that are used. It's all about something in linguistics and linguistic anthropology and philosophy of language that we call pragmatics. And just to be clear, the difference between semantics and pragmatics. Semantics is about meaning of words. It's about the propositional content expressed in an utterance or active communication based on the conventionally understood meaning of terms. Pragmatics, which is something that I spend a lot of time studying, is what is conveyed by the speaker in addition to the information that is literally stated, or really can sometimes be the primary thing that's conveyed. It also highlights that what we do with words is we sometimes think of language as just about the conveyance of information. That is really a very tiny part of what we do with language. We do things with words. If I say to two of you, I now pronounce you man and wife, you are not legally married. But in a different context, if I'm licensed and I have the right people, if I utter those words, I've created a marriage. And so we do things with words. We make requests. We request physician-assisted death. We give informed consent. We do all kinds of different things with words. Those are called speech acts. We perform things. We use language as a performative. Anyway, so that's something that we need to get a better handle on with this, which I'll talk about more. And we need to understand the effects of the utterances on the listener over and above the conveyance of information. So just to give some examples to make this clear, indirect speech acts and conversational applicatures are ways in which we sometimes use words to convey things over and above the literal meaning of the words. Do you know what time it is? So sorry, I was using that as an illustration. I asked you a question. You did not answer my question. I asked, do you know what time it is? The answer presumably would either be the yes or no, right? It was literally the literal meaning of the words that I used was to ask a question to which the answer was yes or no. However, you assumed that there was really no reason why in the middle of a talk I would become fascinated with the state of your temporal knowledge and therefore want you to convey that information to me, and instead made an inference that my intention behind asking that question related to the timing of the talk was to know what the time was. That is, you interpreted my literal question in terms of the meaning of the words as a request. And we can use the same sentences in a lot of ways. When my wife is running late and I go, do you know what time it is? Right? I'm using that same sentence not to make a request, nor to ask a question, but to make a complaint, right, that she's late. You can use it at any moment now I expect someone to say, do you know what time it is? As a nudge for me to get off the stage, right? So you can do all kinds of things. And when you're talking to a patient who has some clinical problems, you might ask it as a literal question, like, do you know what time it is? As part of like a mini mental exercise, right? So, or a MOCA. So anyway, all ways of using the exact same words to perform different speech acts, which depend in complex ways on the context of the utterance, as well as the intentions of the speaker and the interpretation of the listener. We all know if I write a letter of recommendation for a student to medical school that says that that student has really neat handwriting and is very punctual, that is a bad letter of recommendation, and I've just told them over and above the literal meaning of the words, this is a lousy student, do not take them, all right? Again, AI won't be able to understand the semantics of the pragmatics of this, just won't understand the semantics, it won't understand the pragmatics of this either. But these are all things that we do with language, and of course all metaphors are like this, right? When I say my love is a rose, I'm not saying my wife is a particular type of plant or that she has thorns, though maybe I'm using it to say she's thorny, I don't know. Anyway, So what are the implications of all this? The pragmatics of AI facility communication has been understudied so far. We've got these few studies highlighting what we would call perlocutionary effects, the effect that some of these things have on listeners, but we're just at the very early stage of starting to really try and bring these powerful tools we have from linguistics and linguistic anthropology and philosophy of language to really dig in and study what happens in these very complicated communication chains between physicians and patients where they're using AI mediation in all kinds of different complicated ways, some with varying degrees of independence. It could have unforeseen impacts on patients who receive messages and the relationship with clinicians, and trying to figure out the illocutionary force, that is, what type of speech act it is. We just went through what time it is. Do you know what time it is? Can be used to do very different things. How is that going to play out when you're using an AI-mediated communicative tool to create a speech act in interacting with a patient? All of this is very understudied and something that I'm very excited that we're hoping to be able to look into and learn a lot more about. So I just want to end by saying first something about human-to-human communication is hard. It's not just hard, it's harder than you think it is, right? It really, our whole field of study is because it's so hard. Patients and physicians don't, the people who think they're communicating usually don't. They think they're on the same page, they're usually not, and we can empirically study that. So now we're entering using AI mediation on top of a process that is already tremendously challenging. I do think the fact that we've got some evidence of ways it can make it better, so I think AI-mediated communication has potential to potentially make communication better and improve it. At the same time, it can also make it worse depending on a lot of details about how this works out. And I think the inferential chain has to go back, and I think this is the thing I want to end with. It's not just the words that are used or expressed, it's the context and the intention behind it and the inferences about those intentions, which means you've got to see that person behind it who's using it in a mediated fashion, and I'm worried about language that's completely independent and divorced from context and what that would possibly mean. So I'm going to just end with that. Thank you very much.
All right. Well, thank you so much, David, and thank you all for your great talks. And I think Joanna mentioned we have about 10 minutes or so, so I'll start off with one question, but I really would like to leave some time for the audience to ask some questions as well. So my question is, and I was thinking about this as you guys were presenting, it seems striking to me that with ChatGPT being released, all of a sudden we're, of course, very excited about AI and how close we are to AGI and all of that stuff. But at the same time, it does seem like there's been these vectors of progress there this whole time, right? And whether it's around managing data sets and openness and foundational models, and even, well, there's the ethics of AI, which I know, David, you've been working on, but also just something that seemed totally separate, but now very relevant, which is understanding language, like the idea of language, how that impacts how we think and feel in society, which prior to ChatGPT, I imagine wasn't a huge topic in AI circles, but now is there in the middle. I'd love for you to, like each of you, if possible, to comment on one vector of progress that you're closest to, and contextualize that with what the broader conversation of this inflection point in AI. Like where is that vector now, and are there new vectors that we haven't thought of, or are we just kind of talking about the same thing this whole time, but now we all have just more attention paid to it? Jason, you want to start?
Sure. Yeah. I think we, largely enabled by companies like Hugging Face, are way better at sharing stuff now. And the ability to iterate and not replicate work has enabled a lot of really amazing innovation, reproducing results. I think we're not there yet in medicine, and that should be really a first-tier goal, to start really interrogating claims made about these models and their abilities, is to get them, share them in a safe way, right? We have to be very cognizant of the patient protection at play. But getting those out there to test at other places on different populations of humans for people to interrogate in really critical ways, I think that is an area that I think there's finally some consensus that that's critical if you actually want to use AI. And so I'm more positive that will happen sooner than I was maybe a couple years ago.
In addition to obviously increased methods to be able to share models and data sets, I'm also really encouraged by the progress that's being made on the accessibility of these models to be run locally on device, being able to make these models smaller and smaller so that you don't have to think about some of these privacy concerns, which are obviously a big concern when you're thinking about programs like ChatGPT. As well as to be able to more easily fine-tune these models on consumer GPUs. Some of like the parameter-efficient fine-tuning libraries that are coming out these days, I think are really going to be incredible towards making progress on making these models more usable, making them more personalized, and kind of fine-tuning them towards tasks that are really meaningful within healthcare.
Yeah, I'm struggling a little with this question. So I would say the biggest progress that I'm hoping we'll make, though I think it's far from certain, is recognizing language as a contextualized system. And often that's not what happens even in people who study communication between patients and physicians. There tends to be a focus on semantics and the meaning of words and being clear, a little bit on emotive content, and the pragmatics are usually left out. But you can't really do some of that with once you start thinking about language being used through an AI. And so I'm hoping that this is the opening of the door into really recognizing the social context of language to a greater degree than really people have in medicine. People in linguistics have, but it hasn't really permeated medicine very much.
Yeah, I think that's a really interesting point, David, in particular because we've definitely talked about the impact of AI on workflows and the second, third order effects, particularly in medicine, but it's usually assuming that the AI output is some kind of an alert. I mean, there's been so much that's been done about looking at automation bias, automation fatigue, et cetera, but it's all kind of assuming that this AI is some type of alert or something that will discretely change the system, whereas now all of a sudden it's very clear that the impact of AI on people, it's going to be mediated through language. And it does seem like a new vector, right? That previously wasn't really part of the AI conversation, but now is critical. Great. Well, I'd really love to open it up to the audience for questions. So yeah, if you'll just raise your hand, and I'll call on the first one who raises their hand. Go ahead.
Thank you so much for sharing your experience and this intuitive talk. So my question is about AGI, artificial general intelligence. Again, I am a clinician and also a practitioner, so professor at Biomedical University. I am more worried about how AGI is going to change healthcare because I am a bit skeptic with AGI than AI. So what is your take?
AGI is my pet peeve. I hate talking about it. So I think it's very far away. I think we are deceived for many of the things that like David highlighted about how far we actually are because we're glomming onto very surface statistics and these we're being fooled. And I think that'll go away in time, but we're nowhere near close like an embodied agent that operates in the world to be able to understand the types of things that like in theory, AGI might even look like it needs, but.
I would have to agree that AGI is another pet peeve of mine. I think we need to come to a kind of a definition of what AGI means still within the community, and until we do that, I think it's going to be hard for us to really know if we've reached that point. So I'm looking forward to seeing if people are able to come up with that type of definition, and how we think about how that might affect future regulation, for example, or what AI kind of means in the society.
For the ethics of this, I have a rule of thumb. It's hard to predict the future. I've been wrong before, but it seems like this is more than 5 years away, and I have a rule that I don't worry about any ethical issues that are more than 5 years away. So.
Yeah.
I'd like to just add, because you said you're a clinician, and the question was specifically from a clinical perspective, right? Your concern. And I'll just quickly add, as a clinician, an internist, I think your point about how we define AGI is probably, it's really important because AGI means very different things. What I will say, though, is that the difference between working with some kind of prediction model where the only thing it does is predict AKI, acute kidney injury, versus now you have this large language model where you can basically, it can do a lot of things. I mean, it's not AGI, but it's certainly, the output is much more generalizable, much more general in terms of like its different capabilities. So that is a difference, and I'll be honest, I think about it like, hey, this is kind of what I do. What am I going to do that's unique and not purely just retrieving information, synthesizing information, rewriting it, which is a lot of, I think, what a lot of us do, right? So I'll just put that out there as a kind of a devil's advocate. Did someone else raise their hands? No. I think you in the back, you may have raised your hand first. Oh, go ahead.
Hi, this is Ved. My question is for Katie. Even though Hugging Face is bringing so many open source LLM models, but still big companies like Google and Meta are bringing everyday new models which are much larger. How do you see open source community compared to big tech in future for LLM and
I mean, for example, a lot of these companies are sharing open models. I think they do recognize that it has importance for their own progress, helping people build off of their models. I mean, I think we try to be collaborative with everyone, whether you're a big company, whether you're a small researcher. I think we don't want to shut the doors on any progress that's being made. But I really do believe in the community's efforts to create better and better open source models, kind of what Jason mentioned. We need more and more better models, and I really do see the community working towards that goal. Obviously, Google has put out some, or there's a leaked memo that said that that's kind of one of the maybe aspect that might disrupt a moat or so. But I think that they are kind of worried about that type of aspect, but we'll see how it plays out. I think that it's still an open question, what force will win in this battle.
So small startups and big tech, how do you guys see in that way, considering the next few years of AI? Because big tech has some sort of moat, considering the resources.
Yeah, I mean, definitely. There's a lot of moats that can happen within, the compute is obviously very expensive, getting all of this data. If you're a player that's already been in the space for a while, you might have created a large proprietary data set. I do think that, like I mentioned earlier, some of these methods that are coming out where you're able to better fine-tune models on consumer GPUs, for example, I think will help with some of this work. Obviously, we're working really hard to open source a lot of the techniques that are coming out, like RLHF. So hopefully we can, create kind of a community-led movement to, democratize a lot of this technology so that, this powerful technology doesn't just stay in the hands of a few, major tech companies.
Thank you.
Okay. I think we have time for one more question. I think.
Already had the mic.
Oh, okay, sure.
Thank you, David. That was for the funny talk. You made us laugh. So you asked a question, do patients need to know whether AI was used in their care or if they're talking to a chatbot? I know the question was not for me, but I'm going to behave like an LLM and think the question was for me. Yes, we would, but what ultimately matters is, did the physician, like my doctor, was the final decision made by him or her? So the question is, who regulates that? Should it be a regulation? Should FDA regulate? Should the hospital regulate? Should the doctor okay, the final say will be mine. What is that for?
Yeah, I think it's going to depend on the application. So I think most of this is going to probably not be, it's going to be used as a decision support tool and the ways we use other tools in which the clinician will be getting an output and using it in different ways. But there may be exceptions where there's some things which are generally autonomous AI decision making that happens, and some of that might lead to better care, since we know that clinicians often behave in idiosyncratic ways and do things that are not what they shouldn't based on the evidence, and sometimes the data will come in that's better and proves it. I think you still need an agent there there who's going to be the final check and have some notion of responsibility, even if the real decision-making has really been largely turned over. But I think the answer, so I do think the answer is going to be that it just completely depends. That in terms of what the role of physician is going to depend on the particular application and the particular example. And then in terms of what the patient is told, that will then vary with that use. The more the clinician is involved as a mediator, the more this is just like, we don't explain to them like how the EHR works to generate the things that we read. It's as we're looking at a patient chart before going in and talking to the patient. And so if it's like that, well, then that's not a problem. But the more independent it is and the more it's really the driver, even if it's for the best interest of the patient, there may be a threshold where you say, okay, at this point, a reasonable patient would want to know that, and probably the courts will enforce that. All right. Can I ask, do we have time for me to ask a question?
Let's ask Michelle. Do we have time, you think?
One question? I have a question for you about open source, which is, so I'm doing a project around something called dual use research of concern, or sometimes reasonably foreseeable misuse of AI models. And there was a popular or very scary publication by some folks using AI for pharmaceutical modeling, where they realized that, gosh, if we just tweaked our model a little bit, it turns into like a great bioweapons system to help you design new and better agents for warfare. And there's lots of things. And obviously, open source for that kind of stuff could be dangerous. How are you thinking about open source in relation to the increasing recognition that lots of these applications, some of them could be used for surveillance tools by repressive regimes? How do you sort of deal with the tension between open source and the potential for dual use research of concern?
Yeah, definitely. I mean, it's obviously a very big thing that we think a lot about within, our entire team. I mean, when you're using any tool, obviously it's the human that's the one in charge of that tool. And for example, creating bioweapons is, regulated or, illegal. And that's still going to be the case if you're using, whether you're using, traditional methods or you're using like something like an AI model, right? So really, I think we should focus on, that these are illegal use cases. There are ways that we can, moderate some of these outputs, for example. But you can't, right now, there's obviously a lot of large language models that have been released. So you can't necessarily put the genie back in the bottle in some sense. But also, we think that creating models and, open sourcing them for the larger community to do more good or to maybe stop some of these bad use cases is another way that you could think about these models being used in a good way when you open source them. As well as I think that some of the negative effects of keeping them within certain communities or certain organizations, that is a net negative when you're thinking about whether to open or close these models. So keeping that concentration of power within certain hands overall could lead to more negative impacts than positive impacts.
Interesting. Thank you.
All right, thank you very much. A round of applause for panelists.
Thanks, Ron.